Okay, power wagon. This is our first video that we're bringing to you guys on our Holley Terminator X EFI system that we're putting in. And for this video, we want to talk about the in-tank fuel pump. So come here, let me show you what we did. First thing for me, it was way easier to move the bed than it was to drop the fuel tank. 4 bolts, a couple of electrical connectors, and 4 strong teenage boys. Bo had his friends over and they were having a fire. I was like, hey guys, come here, let's move this bed. And that's what we did. So we moved the bed. My tank is right here. So let's look at what I did. So this was really difficult for me, guys, doing this type of work because it involves fabrication, and I am a horrible fabricator. I do not have good vision, and so I didn't film this part live. I apologize. I took clips and we're gonna try to stitch this together. First thing I needed to do was to cut a hole in the tank, and you see the template that I used here. I used the gasket for the pump as my template. So that was the real thick foam gasket. I was gonna put it here because I wanted to use my factory sending unit. I had no way to measure float tank level if I'm gonna put it here. But then thinking about it and the really long sock that's in here, I didn't want that only in the back of the tank. I wanted it more central, because without baffles in here, this is an in-tank electric pump. Without baffles in here, this fuel's gonna slosh around. And that's the point of the really long sock strainer, was that it can pull from various locations as it moves around. So having it back here, I didn't want to do that. I ended up putting it here. It was very nerve-wracking cutting a hole. You can see in this, I'm actually using just a piece of a hacksaw. I was concerned about using a hole saw on this because if I were to hit the metal embedded nuts that are in this ring that I cut out with a hole saw, I was really concerned about a spark. And there's still a little bit of fuel in this tank. The last thing I wanted to do was blow the tank up in my face and have a fire and burn my power wagon to the ground. But I also decided to do that because in the future, I want to move this tank back to the back. I want to put this tank back in here like the Ram Chargers would have. Of course, I would need to redo my exhaust, and that's the point. I want to run true duals front to back in my long tube headers, and I can't. With this tank in the way, my long tube headers, I have about a foot of clearance where it's going to hit the tank. And so I'm like, you know what, if I mess up, then I'll just get another tank. I didn't care. And at that point, I'm like, okay, I'm cutting the hole. And so there it is. We cut the hole. Once I cut the hole, measurements were important. And then also, what am I going to do with this float? Like, how am I going to get gas level? I need a fuel level gauge. Like, I need to know how much gas is in my tank. The cool part about this universal assembly is the hanger that the pump bolts to was the correct length for my pump. I didn't have to do anything with it. It just bolted right up, bolted the pump to it, clamped the pump to it, good to go. But my float was an issue. So I took the old float sending unit assembly and I cut the fuel line off where the float was mounted to. And then I took and I pounded it down with a hammer and I clamped it onto the rod, if you want to call it, that the pump is clamped to. Okay, so here's the setup for the fuel pump. What I did is I adapted my old sending unit. I took and cut the section of line that the float was on. And then I tapped that down with a hammer. And then I just clamped it to the fuel pump housing. And I think it's gonna work great, right? Now, the only downside with that float is the 2 wires that you're looking at right here for the pump are power and ground. I couldn't go through this housing. I didn't want to change this because it's plastic at the top. It's rubber underneath. I could have maybe drilled a hole there. I decided to take the float and run it here next to this basically breather line. It's a rollover valve. And so that is now going to be my sending unit wire. That's going to attach to this, which I haven't done yet. And then my ground, I'm sorry, this is the ground. This ground is going to go with a spade. I'll take this ground to the housing because you can see in this video that I actually did a float resistance measurement to the housing, and the housing itself is conductive. All right, so it looks like I can use the housing. So I'm just doing a quick resistance measurement, and just going to one of the bolts on top so I could run my ground wire right to one of these bolts. And let me hold that there, and the float right now is in the empty position. You see I'm reading 73 ohms, and let's move it to full. You see I'm reading 14 ohms full, so that's right in the range where I should be. All right, next up, supporting ring. This is for a plastic tank, so this just kind of splits. Kind of tough to do one-handed. It's gonna sit right there. Okay, so that gives this pump and these fingers, you know, a metal surface to clamp onto. It keeps it from like warping the plastic tank. So that's what that piece is for right there. Okay, I got the ring in, just use a little bit of JB quick weld. You know, it wasn't what was recommended. I really wish I would have used something different, but it's not critical as long as it's holding long enough to get the pump in, and these fingers are going to hold it into place. So the glue's not holding it, it's just holding it there temporarily while I pull it up. The other thing I liked that I'm seeing is this sock and the way it's designed. You see there's multiple holes. There's 6 smaller holes in relation to the pump housing, and that way you can angle this in 6 different positions depending on your tank, right? I kind of want that sock sitting this way in the tank, so as I'm accelerating, like all the gas is gonna come this way. I want it pulling that from this part. Sorry, that'll be sitting this way, right in the tank. But yeah, I like that. That's a good design, so I can put that where I need it to be. I got my son Bo holding the camera for this. Just down in here, Bo, is where we're focused. I have this pump's gonna sit that way, so this sock's gonna sit just a little crooked this way, which is fine. My sending unit wire, I just knocked this ring off because I was reaching my hand in to grab the wire. Well, I guess we'll pause there while I fix that ring again. So take 2, I used some Right Stuff RTV. This stuff is awesome. I'm gonna let this dry overnight now, and then we'll put this back together. My plan is to, you know, fish the pump in with the sock, and once I get it in, I'll just pull the slack out with this. I'll leave extra slack up here, so in the future, if I ever have to pull that back out, I'll be able to pop this line out and feed it back down in there to pull the pump out, and then I put a you know, kind of quick connector there. And then I'll run the ground pin that was on the old sending unit top. I'll run a ground wire right to one of these bolts. And yeah, should be good to go. But I gotta wait now. That Right Stuff takes some time to dry. Okay, the ring's nice and dry. That Right Stuff RTV was clutch. Again, it doesn't really matter. You know, it isn't the only holding piece, right? Those clamps come down and they pinch on that, so it's not gonna go anywhere. I'm happy with that. That should be it. It's kind of hard to do with one hand. I don't have my cameraman. Let's go. And then as far as plumbing this goes, they sent me rubber fuel lines. I am not doing rubber fuel lines. We're gonna do metal front to back. So I have one here already, but that's gonna get replaced. So I'm running 2 new lines. And the reason we wanna be metal here is we're right above the exhaust. And then all along the frame on the passenger side, the exhaust runs. It's gonna be a hot area. I don't want that rubber. We're going metal front to back. We'll have rubber connections from the pump to the metal line here, and then also up front, but not full rubber front to back. Even though the lines that they sent me are 600 PSI lines, I don't like it because of the heat. Well, that was not fun, let me tell you, running these fuel lines. I had to go with steel or you know, metal lines. Couldn't go rubber from front to back, mainly because of this runs all along the frame and the exhaust is right there, and I had no room to go on this side. But this is that nickel brass fuel line that bends pretty easy, which was nice, but not fun to do. Need a pressure and return line because regulator is going to be up here. This is a return type system. Let me show you in the back. This is our setup. I ended up rotating the pump this way because with the pump facing that way, I didn't want those rubber connections next to this exhaust at all. So I ran them this way. I added the extra length here because of my bed sits, the mounting point for the bed sits over top of the frame just a little bit, I think, and I wanted to stay away from the potential of those lines interfering with the bed, and that's that bracket right there. But yeah, so 600 psi rubber lines, pressure and return, and then the vapor line. Vapor line used to be here, and I adapted it to here because we have a designated vapor port, and then that frees up this hole completely for me for my sending unit. Signal wire for my float that I added. I'll put some RTV over top of that and seal that up. Pressure and return lines, adaptions to rubber right here. I got 2 clamps on the pressure line, which really wasn't necessary. It's only 60 psi, but I did anyway. Just one on the return. And yeah, that's my setup. Runs along the frame. I mean, not the prettiest job in the world, but let me show you underneath too. I still haven't finished the front, but you can see some of these locations here. Like the original line went up there to that bracket, and what that would do is that would run that line right next to my exhaust header. So I didn't want to do that. I moved it down to the bottom by the header. These clamps were key, man. Just using existing holes in the frame. Still got to figure out what to do up front with that. Haven't decided yet on what this is going to look like. I want to get my throttle body mounted, my pressure regulator mounted, and then see what is going to be the best use of this. Also, the alternator is going to be here and things like that, so got to be aware of that. But let's just talk about the wiring real quick. I want to show you guys this on a diagram. This is going to be important for anyone installing these. We got 2 wires here, the green and the red, that are involved in the fuel pump circuit. The red is your battery positive feed. It is already fuse protected. There is a relay inside, and then the green wire is your pump feed that comes from a relay, and these can be wired 2 different ways, with a relay and without. What I've learned is the module can handle up to 10 amps of current to run the pump directly, or you run it with a relay. This kit already had the relay installed, so the computer is really only seeing about 100 milliamps of current, because it's only switching on and off the coil part of the relay. Great design, I like that. What I don't like though, this red wire that goes to the battery, directly to the battery, is fuse protected inside the truck. There's a fuse, that's great. You're protecting the circuit, but you're not protecting the red wire from the battery through the firewall. If you have any issues in that wire is going to melt and potentially cause a fire, which is not good. So I'm going to add an extra fuse. Even though this is already fuse protected inside, I'm going to add an extra fuse at the battery. But I want to show you guys this on a diagram and talk about the design and make sure everybody is clear on how they're running their fuel pumps and how you want to wire them. Okay, fuel pump wiring. The load side of the relay, that's this guy right here, and this looks like a 12 gauge wire. I'm not sure. When I open these up I'll be able to tell for sure, but I got 14, 12, and 10. According to Holley's service info, they want a 10, and I'm thinking, like, looking at that, I'm like, you typically don't see fuel pump wiring that's that thick. But the reason they're recommending a 10 gauge, you know, each one of these have an amperage rating. This one's like 30. Right, that's on the box. The 12 is a 22, and the 14 is a 17. This pump should draw, from what I'm told, about 10 amps, the one I'm using, with 60 psi of current. But Holley makes a whole bunch of different ones that have probably even higher pressure too. So that's probably a factor in the 10 gauge recommendation, but the biggest thing for the recommend, even with my only 10 amp pump, is the length of wire that is going to be run back to the tank. And the longer the wire, the more resistance that wire is going to have, and the more voltage drop you're going to have. And so we'll probably end up going with the 10 as recommended, maybe the 12, maybe. I think this is a 12 that's already on there, but things to consider when you're wiring a pump. And I get it, you know, the pump wires aren't very thick back here, but it's not about that. It's about the voltage drop along the way to get there. So keep that in mind when you're doing aftermarket stuff, aftermarket wiring, things that we don't need to worry about as technicians when we're fixing everyday cars, because all of that stuff's been engineered in and has already been factored in for us. But these are little things that can be missed along the way on builds, where you're not thinking about voltage drops and things like that with smaller gauge wire. All right, so it looks like the Holley wiring is 14 gauge. That's 12 gauge on the top, 14 gauge on the bottom, and then the green is the Holley wiring. And, you know, again, you might be saying to yourself, well, it's 14 gauge from them, why are they recommending 10? Again, it's about the types of pumps that they run to cover all of the pumps, and then also the distance that that line has to run. Green wire right there that runs down underneath, part of the factory Holley harness. I'll certainly be mounting this better, but there's the end of the factory Holley harness, the 14 gauge. Here's my additional 14 gauge wire that I'm running up to my pump. This is only so the pump sits from underneath here. Pump sits like right here. So we're only talking maybe 2.5 feet more of wire that I added up to here. I don't have any problem at all, given the rest of the circuit is 14 gauge that I only added an additional 2.5 feet. Not a problem at all. This wire's even, the one going to the pump itself is even slightly smaller than the 14 gauge that I put on here. Then 14 gauge for the ground. Going to a clean area on the frame. I pulled this off, cleaned this up underneath to where it's bolted. Use a stainless steel bolt and some of those ground washers that have like teeth to them, so it digs in. And we'll paint this too to keep it from corroding. But both my sending unit ground for my makeshift float that I put on here to the housing, that's my sending unit ground, and then this is my pump ground. But be warned on that, it's a legit warning. If you have a tank, let's say you had a long bed, this is a short bed, and the tank was another 2 feet maybe back that way, you're talking like 8+ feet more of wire. You absolutely would want to up that gauge to accommodate for the length of wire and the additional resistance that you're adding. Just be smart about what you're doing here, guys. Now let's address this diagram. Some questions I had going into this, because they show the green wire directly feeding the pump. My question was, how is this wired on this diagram to this fuse and this relay? It shows in the service info that this circuit can handle, from the ECU itself, up to 10 amps of current. So an optional 12 volt fuel pump that's green says used to directly power the fuel pump 12 volts. Do not use this to power fuel pumps that require over 15 amps. Refer to your fuel pump manufacturer for amperage ratings. For high current pumps, use this wire to trigger a separate relay, and use a larger gauge wire to feed the pump. 10 gauge is recommended. So 10 gauge they're saying on this one, 12 gauge they're saying on this one, that's specific to this pump. And I told you guys why, because of length. So that can actually, the green wire can actually feed directly to the pump without a relay. But given the Terminator X system already had a relay wired in, what we're doing with this circuit is we're just triggering the relay. Let's jump over to the other diagram here and talk about options for this on how we're actually running a fuel pump without a relay is really what I wanted to cover. Given I have a relay and the difference between the two, the other diagram is going to help us with that. But I had questions on that, or what are we doing here? Is this ECU or ECM directly powering this fuel pump circuit? the answer is no on this diagram. We're triggering a relay. The relay will carry the load from the red wire up here. Red wire comes down to 30, and then 87 goes to the pump. And so we're only talking about 100 milliamps of current for your ECM controlling the relay. But this ECM, according to the service info, has the ability to run a less than 15 amp pump directly without a relay. But it was some confusing stuff for me. That's how this is wired. The other diagram, let's jump over there and talk about it. It'll help everyone answer the questions I had in this picture. All right, some additional information for the fuel pump circuit. You will not find this in the quick start manual that we've been using. You'll need a PDF of this diagram. It'll be in the description of this video if you need it. But this gives us a little bit more info on how this fuel pump circuit is actually wired. Pin 5 is your engine computer's control of this relay. Let's follow that over real quick. You see it goes to A2. It says fuel pump relay out 10 amp max. So in that quick start manual, it talks about you can use it directly to run a pump, but if it's more than 10 amps, you have to run a relay. We're going to trigger pin 5. That's this guy right here. The opposite side of 5, the control side of the relay, is 2. Right off the bat, I know that has to be a ground, and you can follow pin 2. And you see that it's tied to ground on the ignition, and it's a loose black, one of the loose wires. This goes directly to battery ground. So that means that it is a power side switched control circuit. Computer controls power on pin 5. Pins 1 and 4, pretty standard relay stuff here. You can see that we're going right to the battery with a fuse. 14 gauge wire goes into pin 4, which is 87. And 30 and 87 can be interchanged. This is very common to see this. 87 is hot all the time. 30 is my switched side. You can see that when the relay energizes, it's going to connect pins 1 and 4. So we energize 5 and 2. We connect 1 and 4. When we do that, we're taking 12 volts from the battery. We're going into 87, coming out on 30, and we're running the fuel pump. The other thing that it does is it powers the bulkhead, which is my throttle body. It's going to be your power feed into all of your fuel injectors. So your fuel injectors will be powered up the same time that your fuel pump is running. And this is pretty typical of injection systems. So I thought it was important to see the internals, and this diagram is, again, I'll link it in the description for you guys. This was really important for me in figuring out what I was going to do with the wiring and making sure I was fuse protected properly and making sure I wasn't going to, damage my computer and all of those things. So it's important to have it. That was pretty much it. Pretty straightforward pump installation. I'm very happy with the way it turned out, and we also have a fuel pressure regulator that we need to install too, and we'll get you guys a video on that as well. Stay tuned for this series as we go. We'll do these in segments, and then once we get this running, we'll have a tuning one as well. It's going to be pretty awesome. I cannot wait to hear this live. We all heard it at Jamsey online on their page with the build and on an engine stand. That was pretty awesome. We have not heard it ourselves yet, and I'm getting antsy. Soon. Thanks for following, and thank you, Holley, for being a sponsor for this build.